Hello everyone. Today we are going to solve problem number 646, maximum length of pair chain. So let's first read the question. You are given an array of n pairs where pairs at I is equal to left at I, comma right at I, and left at I is always less than right at I. Also, a pair P2 C comma D follows a pair P1 A comma B. It means A comma B is followed by C comma D only if B is less than C. So if B is less than C, the last character of previous pair and the first character of current pair. A chain of pairs can be formed in this fashion. So we can have a pair E comma D where E should be greater than D. In this fashion we can form a chain of pairs. Return the length of the longest chain which can be formed. So we need to just return the length of the longest chain. You do not need to use up all the given intervals. So we can either we can choose few intervals which we want and we can leave the rest. You can select pairs in any order. Also the order is not fixed. So when you see the order is not fixed of taking the elements, what we can do is we can first sort the given array of pairs by the first element, the in the start of interval. So this is already sorted in that order, but in the second example we see that it's not sorted. It's 1 comma 2 7 comma 8 4 comma 5. So after sorting it will become 1 comma 2 7 comma it's 4 comma 5, then 7 comma 8. So on the first look, you might think that, oh, the problem is very simple and we can simply sort like this and do it greedily. But the problem occurs, let me first walk you through what I mean. So if you look at this, you might think, okay, we will take 1 comma 2 and then we'll compare 2 by 4. If it's valid, we will take this. And similarly, if 5 is less than 7, then we will take this. Or if not, then there might be something like 9 and to the other, then we'll take pairs accordingly. So what's wrong in this approach is, suppose we have a number here 1 comma 10. Then what happens if we do this greedily? We will take the pair 1 comma 10 and next we'll try to find the number greater than 10, which we can't find, and our result will be 1, which is wrong. So thus we know that we cannot move greedily. So what we need to do, so we have seen a type of problem, subset problems, where we take pairs, we take certain numbers. So the resultant answer will be just a subset of the given pairs array. Suppose we have this. So we know the result will be a subset of this. So what we can do, we can do this using dynamic programming as we solved the yesterday's problem. So now let's look at the approach of how to solve this problem. So to solve this problem, we know that we require an index. So we will require an index. So first of all, we need to sort it. Sort the given pairs by first element. Okay, next we will have a function which will return the result. So let's see the function below. So we will have a function f which will have two parameters. One parameter will be index and the second parameter will be what was the previous element, because we need to know the previous element to either to include this element or to exclude it. So if we somehow reach the last element, so if index is equal to len of pairs, that means we reach the last element. So this will be our base case. So when there are no elements, we know that no chain can be formed and the length of the chain will be 0. So we return 0 in this case. And for the rest of the cases, we have two options. Either we can take this or we can not take this. So if we do not take the current index element, the index will start from 0 and go till len of pairs. So not taking is quite simple. We simply need to call index plus 1 with the previous value of pair. And if we take this, we will have 1 plus the answer returned by index plus 1, and the previous will become pairs at index and the second element. So where the current pair ends, it will become previous for the next element. And we can also only choose this option when previous is less than the first element of current pair. So at the end we need to return the maximum of both the options. Take and not take. Then we need to memorize this using DP. So in memorization we simply check if DP at index and previous is already present, we return the same, and here at the bottom we save the value for that index and previous. So now let's see how we are going to code it. Let's see how to code it. So we'll start by making a utility function, util, which will require the pairs, and we'll need an index to iterate over this, and we also need previous. So if index reaches the last, pairs dot size, we simply need to return 0, and we'll have two options, take 0, not take is 0, and at the end we'll return maximum of take comma not take. Now in not take it's quite simple. Not take will be util pairs, we move index one step ahead and previous will remain the same. In take we can only take if previous is less than current pair first element. So if this is the case, we take it, and if we are going to take it, we will add 1 for the current pair and we count it, and we call utility function for index plus 1, and now the previous will also change. So what will previous become? It will become pairs at index and the last element of this particular range. So, and at then we need to return util pairs index will start from 0, and what will should be the initial value of previous. So as we see here in the constraints, the minimum value of left can go till minus 1000, so we will take a value lesser than this, minus 1001. So it is guaranteed that we get a minimum element for a new start of the chain. And also we need to sort it out first. So sort pairs dot begin pairs dot end. If we try to run this, you see the sample test cases are passing, but it is not the optimal solution. So in order to optimize it, we will use memoization here. So for this we make dp of vector, and the start we resize it, dp dot resize. So we see the what range can index move. Index can move from 0 till the length of pairs. So it will be pairs dot size, and we see next, and what are the values previous can go to. So previous can move from minus 1000, minus 1001 here till 1000, but we know that there are no negative indexes in an array. So we will take, so we see our previous is going from minus 1000 till 1000, so we try to make it positive by adding 1001 both sides. So now our previous will go from 0 till 2001, and to get an index of 2001 we need to make an array of 2002, and the initial value of this dp will be minus 1 because no chain can have a length of minus 1. So we first need to calculate a new previous, so we'll call it pr. This will be previous plus 1001, and then we check if dp at index and pr is not equals minus 1. This means that this index and pair have already been seen before, and the answer also must have been calculated previously. So we simply return dp at index and pr, and at the bottom we will store this value dp at index and pr. Now let's check if it runs. Okay, the sample test cases are passing. Let's try to submit it. So it's getting submitted. So this is how memoization works. We can also do the tabulation solution and then again optimize it, but we'll stop here. So now analyze the time complexity of this problem. So let's suppose the size of this given pairs of vectors is n, and for each n we can have at least n minus 1 elements to form the chain with. So in total we will have n cross n time complexity, and the space complexity will be n cross 2002, or simply big of n. So thank you. See you in the next video.